So I'm going to give you, for all the quizzes and the exam, these reactions, right? And you recognize in each type of reaction, there's 4 of them, in each type of reaction, an acid is there. So for me, that's the first thing that I want you to recognize, is because we have solubility problems to worry about too. And that's not listed as one of the 4. So how do you know whether it's a solubility problem, that we, just like the quiz, or one of these that you have to worry about? Acid. If you see an acid, this is what you focus on. It's got to be one of the 4. Do you see the game plan? So if you don't see an acid in the reaction, geez, that's that solubility problem. Everything you've just been working on for the quiz. Okay? But if you see an acid, it's one of these 4. So how do you recognize an acid in the first place in a chemical reaction? Danielle, what does an acid look like? The only way that you can really know this is if you've done a bunch of these, I think. Does anybody know? Hydrogen. There's a lot of hydrogen ions. That's what when I think of an acid, there's a lot of that stuff. So it's something that produces a lot of hydrogen ions. So if you have H and then write the rest of the compound, it has an H out front, right? That will be an acid. That's how we're going to recognize them. Okay, so far? But not only in that reaction, you have a base too. If you have a base, you have something that's producing a lot of what? Anybody know? Not H pluses anymore, but hydroxides, right? There's a lot of hydroxides. So you have to have hydroxide in there, right? And then there's something here. Okay. That's how I remember this. Okay. So how you recognize a base? If you see hydroxide in the compound. How do you recognize an acid in a reaction? Oh, you see an H out front. Oh, it's got to be an acid. Okay. So let's play this game a little bit. This is not in your notes. I'm just kind of showing you the big picture. We have 2 things to worry about, Tegan. And this cheat sheet, this is what I want us to depend on, right? It's either got to be solubility or one of the 4. So you take a look at this first one, this first reaction. Would it be solubility or is it one of the 4? Solubility. Everybody agree? I see an acid. Right? There's an acid out front, so it's got to be an acid. Has to be one of the 4. Has to be in the front. Right? Okay. It doesn't matter whether it's written first or second, right? It's because A plus B is B plus A mathematically, so that doesn't matter. But you have an acid, so it has to be one of the 4. Which one is it, Clarissa? Which one is it? Right? So here's our acid. That's our acid. Which one is it? Now, it might help to write charges on stuff. Right? We know H is a plus, Br is a minus. Calcium is a plus 2. Sulfide must be a negative 2. Does that help? Which reaction is it? It's number... Well, we have the acid part, but I don't see a base. I don't see a hydroxide, so it can't be number 1. Number 2, I see the acid, but I don't see the carbonate. Keep going. You'll get there.
I guess
Number 4. Do you see it? I don't mean to put you on the spot, but it really helps everybody else because they're going through the same thinking. Oh, sulfide, that's negative 2. It's hidden. The sulfide is hidden. It's there. It's just with calcium, so you don't see the negative 2. That's why it helps to write the charges. And you're going to have to write the charges anyway because you have to write molecular, ionic, net ionic. You might as well write the charges. It's going to help you a lot. So write the charges. So it has to be reaction number 4. Has to be reaction number 4. And we'll finish it. That's what we're going to do the rest of the hour. I'm just trying to identify them. B. How about B? Allison. Is it solubility or one of the four? That's the first question you always ask yourself. She says it's one of the four. You agree? Yeah. Who knows what this is? It's vinegar, if you don't know it, but it's vinegar. It has H out front. Has to be one of the four. So which of the four, Jonathan? It's number one. He sees the hydroxide. Very good. How about C? Oscar. First one again, number one. Oh my gosh, thank you. We're on, who am I picking on? I want to pick on, I just picked on Alejandro, didn't I? No, I didn't. Alejandro. D. It's 3. I agree totally. Right? E. Diana. Solubility. Because she doesn't see an acid. You don't see an acid. So it's got to be solubility. Very good. All right. So that's the game we're going to be playing, except we just have to finish the question. Right? Okay, there's a few more rules before we get to the game, though. We talked about these acids. Not all of them are strong. Again, it's not in your notes. Almost all of them are weak. Okay? Do we care? You're going to care. But why? The reason why you care is just what it sounds like. A strong acid, that's the stuff that they use in Breaking Bad to do all the stuff that's bad, right? The weak acids, oh, that's the good stuff. That's the vitamins. That's the vinegar. That's the stuff that we eat, and right? That's the nice stuff. So the strong acids break up completely. They are very strong. They break up into their ions. So in the ionic chemical equation, you have to break up strong acids. Weak acids, you do not, right? So in the ionic chemical reaction, break up all strong acids. Break up all strong acids into their ions. And we'll practice that. Strong bases, they're also broken up into their ions. Okay? I just use solubility rules. It's so much easier because I don't like to memorize all this stuff. But I just want to name a few common strong bases. And remember, base is supposed to have what anion with it? If it's a base, it needs to have what? OH. Okay. Now, I don't know if you've noticed this yet, but your life will be so much easier, Christian, if you notice this. What group number, right, can I put with anything? It will always completely dissolve. Because hydroxides are those funky ones. They form precipitates. I can put those right here, and I'll always have a strong base. I can put it with anything. It'll dissolve. What was it? I don't know if you've noticed, because it wasn't in the chart. They didn't. You had a different type of chart. You followed different rules. But it's a very useful rule. Does anyone know? Anyone recognize this? After doing a bunch of problems? Whenever you had lithium, sodium, potassium, those alkali metals, it doesn't matter what it's with. It's always AQ. Always. So heck, that means lithium hydroxide, strong base, right? Sodium hydroxide, strong base. Potassium hydroxide, strong base. So just remember that one, because it's going to save you a lot of time. Alkali metal with anything, always AQ. Always break up into its ions in ionic chemical equations. We need to know the names and formulas of the 6 strong acids. Now, acids always have what out front again? H, so let's put in all the H's. Okay, hydrochloric acid, because Because I'm sure some homework questions, Annabelle, are going to say hydrochloric acid instead of giving you the formula. So we got to know both. Hydrochloric acid. The hint is the chlor, I guess. Cl. Hydrochloric acid is HCl. Hydrobromic, anybody? HBr. Hydroiodic. HI. Sulfuric. Now, to know the trick for this, you got to know what sulfate was. Sulfate was SO -2. So how many H pluses can you attach to it? Two of them. So it'd be H2SO4. Nitric acid, remember what nitrate was? NO3 negative, so it'll just be HNO3. And in perchlorate, I don't think we ever really use that much, but so that's just HClO4. Okay. So these strong acids, you always break them up into their ions in the ionic chemical equation. We're almost there to start doing this stuff, except there's an oddball. Ammonia. Ammonia is NH3. And the reason why we're talking about base is because it's there. Where's our list? Here's base. You're almost always going to be using OH minus, but NH3 is a base too, so you got to worry about him. He'll be there, and he'll bite you in the back if you don't remember it's a base. You got to know what he does. Ammonia reacts with H plus to make NH4 plus. That's really different than every other single base, right? All these other bases, they're always OH minus plus H plus makes H2O. That's everything else. Okay? So we're just kind of got to remember NH3 is a base. Remember that's a base. Okay, let's try one of these. Let's do this one together. Now everything's free game here. I can have solubility in there, and I can have reactions 1 through 4. So, Dulce, which one is this? Now you should have that cheat sheet. If you don't have it, tear it out of your book, man. It's not going to do any good sitting in there. Which reaction is this? She says it's the first one. Everybody agree? Yeah, it's reaction number 1. So get into this habit, man. I can't stress this enough. So many people don't do this. The power of the cheat sheet is you copy it. She said it's number 1. So you copy down what the answers are. The answers are H2O liquid plus salt. Now don't write the word salt, but we can at first here. But we'll never do it again, hopefully. H2O liquid plus salt. Now salt we're going to have to erase. Salt is just everything left over. So what's left over? Well, the hydroxide ripped off that acidic hydrogen. Right? But it's also kind of, if you can see that, great. But if you can't, man, I strongly suggest writing these darn charges everywhere. I mean, we've memorized all these polyatomic ions. Let's use it. And then it's really easy to tell what's left over. I think it's a lot easier. Because to get this water, right, here's my hydroxide. It ripped off that H. And I got HOH, which is H2O. So then it's really easy to tell what's left over and write their charges. So get rid of salt. Write their charges, because their charges give you the chemical formula. Get in the habit of writing these charges, right? And then the charges become the subscripts, right? You do the cross thing. Okay? And then we need to balance it. Let's see here. We had only one OH, grabbed that one H, so we only made one H2O, and there's one acetate, one sodium, and everything's balanced, right? Now we need to use our solubility rules to write solid or aqueous on everything. Okay. Now you can use the solubility rules for all these acids. And you're going to find that every single one is aqueous. All acids are always aqueous. And you can use the solubility rules if you don't trust me. But they're all aqueous. And remember that trick. Sodium, lithium, potassium, all aqueous. Whenever you see it. I mean, don't even bother looking at the solubility rules. It has to be. See why it's important to copy it from the cheat sheet? The liquid on the water? Yeah, because then you don't have to worry about it. He's done already. Okay. So that's my molecular. I need the ionic and the net ionic. Okay. The ionic, do I break this up? I wrote AQ on it, but life is more complicated though, because it's an acid. You only break up which acids? Strong ones. Is he on the list of strong? No, so you don't break them up. That's why you gotta know the list of strong acids. Because if it's not on that list, oh, it's weak, I can't break them up. That's the reason for knowing all these. Okay? So do not break it up, so we just have to write it as is. Copy it down. Yeah, definitely break up sodium hydroxide. We've already figured that out by writing AQ there. Don't break up liquids and gases. Never, ever. Break up the sodium acetate. And then we're ready to write our net ionic. What cancels? Anything? Yeah, I think we have something. Not a whole lot to cancel, but there's something. So it looks like the hydroxide reacted with our acetic acid, ripped off the acidic hydrogen. We made water, and the acetates left. The sodium did nothing the whole time. It just floated around, so it didn't do anything. Okay? So that's the game we're playing. So first, identify whether it's a solubility problem or a reaction 1 through 4, and then you head after it. Okay? Now, what's that? Good question, Daisy. You don't break up weak acids, so it's really important to know what's weak. 2 ways to go about it. You could know all the weak acids, but there's tens of thousands of them. But there's only 6 strong acids. So know the 6 strong acids. Then everything else is weak. Then you don't care. Oh, it's got an H out front, not one of the 6. Ah, weak. Don't break it up. That's how I figure it. That's how I think about it. Okay. So I want to jump down to potassium sulfite and HI. I think that's G in your notes. Right, is that G? Yeah, that's G. Change that to G. Okay. Try this one. Potassium sulfite and HI. The first question you ask yourself, solubility or reaction 1 through 4? And have that cheat sheet. Try not to use your notes. Try to depend on this cheat sheet. Okay? Use the cheat sheet. So anyone not sure what to do? Jorge, which reaction did you say it is? 3. Yeah, great. So he says it's 3, so hopefully the first thing that he did was he wrote this stuff down. Right? That's the first thing you should do after you identify the reaction. And then combine what's left over. And to figure out what's left over, write the charges up there. Right? Write the charges on the potassium and the sulfite and the H and the I. And it'll really help you out to identify what's left over. And salts are always a cation and then the anion. Right? All salts are written that way. You have to write the cation, and the anion is next. All right? That's how you write all salts. Use the formulas. Right? I know sulfite's a -2 because I see the formula right there. And I can also look it up on the solubility rules. So Christian, what did you say what's left over? How did you write your salt? Potassium. So hopefully you just write K plus and the iodide. And the I minus. So it's going to be 1 to 1 when you move the charges down. Good. Everybody agree? What's that? Christian, where'd you get that? He recognized the sulfur, the oxygen, and the hydrogens are all used up. So that means this stuff is gone, this is gone. The only thing left over is that and this. Do you see that, Annabelle? Okay. So we're forming SO2. So where do we get the SO2 gas and the H2O liquid? That's from the cheat sheet, right? So you know the sulfur and the oxygen and the hydrogen, they're reacting. So what did not react? And what did not react? Well, I don't see any potassium there, and I don't see any iodine there. So that's why we combined them. They had to go somewhere. So you got to write them somewhere. And you always write the cation first. Now, before you keep going, though, Erica, are we balanced? We have 2 potassiums with the sulfite, but only 1 potassium with the iodine. So where do I put the 2? How do I balance it? All right. Let me show a common error. Common error is to write the 2 right there, because you see a 2 right here. No, right? This is K plus. The only way you get a 2 right here is if that's a -2. Remember doing that? So if you want to balance, you have to put the coefficients. So you have to put a 2 right here. Remember doing this? Okay, now I screwed up the iodines, though. So I got to put a 2 in front of the HI. Screwed up the H's. Oh, no, I didn't. I have 2 H's. Okay, now do solid or AQ. Make sure everything has a subscript. The gas and liquid are already done. Yes? Well, no, they're totally different because this is SO2 gas. So he will not cancel out with the SO3 -2 in the ionic equation. He won't. They're 2 different things. They have to be identical to cancel out. So put subscripts on everything. And remember the rules. If you see sodium, lithium, or potassium, dang, just write AQ right away. All acids, AQ. All right. So Melissa, now what? What'd you do next? Did you get this far? Now, okay. So what would you break up this first one to? 2, not 2K, not K2. 2K pluses, right? Because why? What does that 2 do in there? It's because I have 2 potassiums. Okay, 2K pluses plus SO3, good, keep going, with a what charge? With a -2 charge. Okay, you're doing good, keep going. Have to have charges though, H pluses. Good. How many I negatives? 2 of them, because we have 2 HIs, so that means that'll give us 2 H's and 2 I's. Okay, let's keep going, Daisy. That gives us what? With a little subscript G, okay, and yeah, and good. Everybody agree? Okay, there's got to be, Jorge, and something canceling in this mess. Anything canceling? Yeah. Really? Oh, yeah. Okay. Oh, they have to be identical. SO2 is close to SO3, but they have charges, and one's a gas, one's an ion. Yeah, there's no way.
No, but that's solids.
What's that?
That was a solid.
Oh, no. They have to be identical to cancel on both sides. Yeah. Yeah, SO2 is a gas, and that's copied from the cheat sheet. So then just copy everything that's left over. And make sure you write those charges on the ions. You can leave off AQ, I'll give you that one. But I will not let you off on the charges. You got to write those. Okay? So Katrina, you see what I did and why we did what we did? All right. So what, Katrina, in your notes, which question is this one? Sodium sulfide plus nitric acid. It's what letter?
Like what number?
Yeah, what number is it? It's H?
Yeah.
It's H? Okay. Do H next.
Oh.
Do H next. If you get H done, go on to D. Or just write down D. You may not even have D. Okay? So identify which game you're playing, whether it's solubility or one of the 4, and go from there. If you're not sure, it's a great time to ask right now.
Okay, so there's this, and then I saw obviously H.
Yeah, so you know it's got to be one of these.
So would it be this one?
Yeah, because you even helped yourself out. You have the S negative too. So it's got to be that one. So the first thing you do is write this. So you don't forget to write it. It's perfect. Yep. Make sure it's balanced though, because I think you have 2 sodiums here, so you have to put a 2 in front of this one.
Wait, so would this be the molecular already?
Yeah, we should have wrote molecular on it. That was molecular. So we're writing the molecular.
So then write the molecular.
No, this is the molecular.
That is.
Yeah, this is the molecular.
Okay.
So we need 2 NAs. So you have to put a 2 out front here. But then we screw up the nitrates, so you got to put a 2 in front of that one. Yep. Sulfide. It has to be this one. it would be this one if you had SO3, but you have an S. Oh, and I think what would help you is this is S negative 2, and that's a plus, right? And then if you write that, you see, oh, S negative 2, S negative 2.
Otherwise, it's insoluble.
So that one is the molecular.
The sodium. No. Yeah, the sodium sulfide. I mean, sodium sulfide. That's solid. Then HNO3 will be equals this NO3, and there's no exceptions. This is solid.
So I see a lot of you writing the charges. That's great, right? So then you see the S negative 2. So it has to be reaction 4. Right?
So when you call it two out front, you always have to, it's always going to be two each.
Yes, that's kind of the lazy way of writing. Like if you have 2 HI, you could just, that's the lazy way of writing HI plus HI. It's just less writing. But it probably would be better if we did do that, then we wouldn't screw up so much. But so there's my molecular. I don't have the subscripts on yet, but it's balanced. So I had to put a 2 in front of the nitric acid and a 2 in front of the sodium nitrate. Alkali metals, they're always AQ. All acids, AQ. Uh-huh. Okay, because you have, okay, you got your acid. Now you have to figure out which one this one corresponds to. Has sodium, doesn't do any good, but that S negative 2, there it is, S negative 2. For it to be this one, you have to have carbonate. But we don't, all we have is the S negative 2. Right? And then help yourself out by don't do this.
I thought you said to do that.
Yeah, we did, but that's nitrate. That's a negative. That whole thing goes together. Right? Memorize nitrate, NO3 minus. So that's what this is. Right?
So it's this one.
It has to be that one.
Since it's a strong acid, don't.
Strong acid, you have to break it up.
Oh.
It's the weak ones you don't. So you have to definitely break him up. It's into 2 H pluses plus 2 NO3 minuses.
And then that's it.
Well, what subscript do you put on here? G. Otherwise, when you get to ionic, you might think you got to break it up, but you don't. Okay?
So the gases, the solids, we don't break up.
Yes. And liquids too. Anything other than AQ.
We break up.
Mm-hmm. Unless it's weak. Like the whole acid thing, remember? Okay. Now you got two sodiums, but But now you have 2 nitrates. So you have to have a 2 in front of that one. And remember, nitrate's a -1, not -2.
I get nitrate and nitrite.
Or then nitrate is NO3 minus, nitrite is NO2 minus. So keep going. If you got the sodium sulfide one done, keep going. See if you get the same as me here. 2 sodiums and a sulfide would give me, break up that acid because it's strong. I need 2 nitrates. Don't break up gases or liquids. See what we can get to cancel here. That guy's gone. That's gone. Okay. Okay. H pluses. H pluses.
Okay, so it's only.
So, because these are always H pluses,
Yes.
that should be a plus. Okay, and then what's your question?
The H2O.
Yeah,
So
what's?
I have to balance the H's. Is that 3 to 2, or is that different?
Let's bounce it up here. It's easier. So you've got 2 H's, and oh, you have this one too. That's
Yeah,
3
that's
H's.
one
Oh, but
down.
we have 2. We forgot about the sodiums. So put a 2 in front of here.
Okay.
Now your sodiums are balanced.
Oh, okay.
Now I bet you it works.
Thank you.
Let's see if you're getting this one. Carbonate, that should be CO2 gas and H2O liquid. And then write what's left over. Well, I've got a plus and a minus, plus and a minus 2. So I've got my K plus left and the bromide. All right? I just made it up. I need a 2 here and a 2 there. And I can scribble down aqueous really quick because I see potassium everywhere. Right? Okay, that'd be my balanced molecular equation for potassium carbonate
Is it
plus.
CO2 gas?
Yeah, so it's on the cheat sheet. CO2 gas. That should be a G. But yeah, you copy it from the cheat sheet. Okay. So there's a bunch on here. You can never get through them all. There's a lot. But practice them. Try the homework. I'll be glad to help you out. Okay. This week we'll be doing a lot of this in lab, so that'll help you out too. So have a good day.